A cubical block of size 7 centimeter is surmounted by a hemisphere. So let's understand what is this surmounting means. I have a cube, right? This is a cube. On that, if I happen to keep a hemisphere, it's said to be surmounted. We are surmounting a hemisphere on a cube. Basically, you're placing something on the cube. That's it. Nothing else. Surmounting means you're placing that thing on the given object. Okay. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So there are two questions in this. So they're asking what is the greatest possible diameter. So what does it mean? Well, just a second. Wait, I had to think I have to. Yeah. So see, this is a sphere, is it not? Now, if I happen to increase the radius, it will become that big. If I decrease the radius, it will become that small. But I have to keep it in such a way that it exactly is on the hemisphere, something like that. And yes, done. So they want us to find this. Yeah, this is an exact diagram what we wanted. They want us to find the diameter of this maximum possible side. Okay, again, we can make it small or very big, but surmounted means it is so. You have to do it in this manner. So answer diagram. So here the length is 7 centimeter, right? And the diameter is what they're asking. Simple. This is the chord with the highest length, and this will be by default 7 centimeter. Is it not? The radius will be half of that, right? So the radius is 7/2 centimeter. It's better to write. Okay. So we'll begin with writing the given. This the length of a cube is 7 centimeter. Next, greatest diameter of hemisphere is equal to the same length as that of the cube, right? Okay, now find the surface area of the solid. So total surface area of the solid. This is where it gets tricky. So let's just not make it too complicated. Let's just look at it let's just look at it. Let's just look at it. Oh, that's what I meant to say. Let's just look at it as a part by part scenario. That is, first we have the cube. So total surface area of the solid is equal to total surface area of the cube plus what else is there? Plus the cone is there, right? This is your curved surface area. Curved surface area of the cone. Okay, we need to write the dimensions. It always helps. 7 plus curved surface area of the cone with radius 7/2 centimeter. Okay. Next, the thing is, we won't be able to see all of the cube. Is it not? See, this part, this upper part, right? If I cross it, I mean, imagine me crossing it. So if the sphere is there, that is not visible. So basically, if I happen to view from the top, see this part of the, right? This part of the cube is not visible when I keep a hemisphere. So what is this part? What is this surface? It's not a volume, remember, it's a surface. So what is this surface? What does it look like? Forget about it being 3-dimensional. What does it look like? It looks like a circle, is it not? So we need to subtract the area of a circle whose radius is 7/2 centimeter. So it's very clear from this as well. So we are not able to see this, right? I'm talking about on the surface of the cube. Is it not? That is not visible. So where did that disappear? It's under the cone. So we need to subtract that. So what is not visible, that has to be subtracted. And cone, we are considering the curved surface area of a cone, not total surface area of the cone. Simple reason being, the bottom of the cone, right, is not visible. Okay, if I remove the cube, so the bottom, if it's kind of flat surface over there, it's not visible. If I keep the cube, is it not? We just considering the curved surface area. So total surface area of the cube is 6 into a square plus this is half of 4 pi r square, right? Minus this is pi r square, right? Now, so 2 ones are 2 twos are. So I'm going to do something weird. Please don't freak out. Minus 1 pi r square. These two are kind of like terms, because if I take, I'll make a small note over here. If I take x as pi r square, right, I'll end up with 2x minus 1x, right? In place of pi r square, I'm writing as x. So 2x and minus 1x is 1x. So basically, this entire thing will reduce to what? Right? 6a square plus 1 into x. In this case, x is pi r square. Okay, so it's not too difficult. I hope I made it easy. Also, so the dimension is 7 into 7 into 22 by 7 into radius is 7 by 2 into 7 by 2. And remember, this was possible because both have the same radius. If not, this would have been R1, this would have been R2, and I could have not done much. So 7 and 7 gets cancelled. 2 ones are 2, 11s are. I should be changing the color. Okay. And now it's just a simple calculation. 6 into 7 into 7 plus 11 into 7 by 2. So 7 is common in the numerator. So we have 7 into 6 into 7 plus 11 by 2. So this is 2 by 2. Okay. And so we have 7 by 2 into 14, 84 plus 95, right? And so 7 into that is 35, 63, 66 by 2. If they want you guys to convert to decimal, it's easy. Divide by 2 is always easy. 332.5 centimeter square. If it's in decimal, sorry, fraction, this is the answer, right? Quite simple. So have a look at the answer.